Hello students, welcome to my sessions. Today we are going to discuss about inverse proportions. Look at this diagram. It shows a hourglass. Here that in above area that sand will fall to the below part. When we consider this low area, the volume of sand, it increases with time. That means it falling, so that volume increases. So we can say that with time this is directly proportional. That means the volume of sand is directly proportional to time. That is mathematically we can notate like this: V, that means volume, proportional to time. Similarly, if you consider this area, here the volume of sand decreases with time. Here increases with time, this area decreases with time. So when time increases, the volume of sand here decreases. So we call that inverse proportion. So mathematically we can denote volume proportion 1 upon t. When time increases, volume decreases. This is what two type of proportion we have learned. This direct proportion already we have learned. Today we are going to discuss about inverse proportion. Algebraically we can represent like this. If you consider this area, we'll give you an example. This table shows that with time 2 seconds, 4, 6 up to 10 seconds. Imagine that volume here initially 20 centimeter cube. Then it decreases gradually. After 10 seconds, it becomes 4 centimeter cube. Then if you multiply these two, time into volume, then 2 into 20, 40, 4 into 16, 40. Like that, if you multiply these, always you are getting the same answer, that constant value. Then according to this, already we discussed that we learned that this part is inversely proportional. That means when time increases, volume decreases. That is what the table also shows. Then time into volume of sand. Time into volume of sand. These two, if you multiply, always you are getting the same answer. That means constant. So algebraically we can note down, if you consider time as x and variable sand volume, that means y, then if you multiply these two, you are getting the same answer. So constant value. This is what that algebraically we can represent this inverse proportional, that relationship. We are going to use this idea in further develop. That means next examples we are going to use this idea. I'll explain how to apply this idea. Consider this first example. It says that 5 men takes 12 days for a work. What is the time in days needed for 4 men to complete that work? So first of all we have to find how many hours we have to work. That means total human hours we have to find, or human days we say, total work, how much we have to do. So here 5 men, they are doing 12 days, then that is what the total work. If you consider that total work 60 human days, that means 5 humans or 5 men into 12 days, that is 60 human days we call. This is what the total work we have to do. Then that question says, when 4 men, that means initially 5, now 1 left, that means 4, then how many days will it take? So we don't know, make it x days, but the total work remains same, 60 human days. So if you solve this one, 4 into x days, that is 60. So 4 into x equals 60. So x becomes 15 days. That means 5 men, they are working 12 days. This much of work they are doing. Same amount of work if 4 men do, then x days, that means 15 days they will have to work. That is what that answer. We'll consider the second example. It says that it is necessary to engage 5 men for 4 days at 5 hours per day to clear a certain land. 9 men, 4 days they have to work, per day 5 hours they are working. Now it says, how many men working 6 hours per day? Now the time is increased. Complete the same task in 10 days. So earlier 4 days, now 10 days. Now to handle this problem, first of all, we have to find the total work. How much we have to work? That is, we can find like this. 9 men into 4 days they have to work. Every day 5 hours. That means 9 into 4 into 5. That is 180 human days hours. This much of work we have to do according to this example. Now second part, that means now they are telling earlier they did 4 days and 5 hours per day. Now 10 days they are working 6 hours per day. Then how many people we need? Then we don't know, make it x. Now if you write as an equation 10 into 6 60 into x. X means number of people or number of men we need. And 180, this is the total work we have to do. Then x becomes, if you simplify, 3 men. Now you have to understand 4 days per day 5 hours they are working. Then we need 9 men. So this is that work they did. Now 10 days they are working, each day 6 hours, then we need 3 men. That means the same amount of work, to do this much of work we need 3 men. This is the answer for second example. You have to consider always how much we have to work. That means total work, what is the total work we have to do. That is what that first step we have to find. Okay, we'll move to next example number 3. This is slightly different from others too. It says 4 laborers need 5 days to do a job of work. If one laborer gets absent for 3 days, how many more days are required for the 3 men of them to complete the said job of the work? Now we have to understand there are 4 laborers. We have to analyze this question. Through diagram we can find like this. Initially we had 4 laborers. They are working 5 days. Then if you multiply these two, you can find how much the total work we have to do. That is first part. Then it says one laborer absent for 3 days. 5 days totally they are doing, and 3 days one laborer is absent. That means 2 days he has worked with others. That means all 4 laborers 2 days they have worked. Then 4 laborers into 2 days they have worked. Now one laborer left means rest of the work we have to do by these 3 people. Now these two if you multiply, you are getting the total work done. Out of that total work done, already they have finished this part. That means 4 men together 2 days they have worked, and rest of the work will be done by these 3 people. So we'll calculate this one further. I'll explain further. Now as what I said initially, 4 people they have to do 5 days. Then this is what the total work they have to do. There is a work to be completed. If there is 4 people, then 5 days they have to work. Now one laborer absent for 3 days. That means all 4 laborers they have worked 2 days. Out of 5 days, 3 days one is absent, means 2 days everyone is there. Therefore 4 people they have worked 2 days. That means already they have completed 8 human days work they have completed. We have to understand that first. This is what total work we have to do. Now already they have completed this much of work. Then we left with 12 human days. That means out of 20 human days work, 8 human days work we have completed. So we left with 12 human days. Now for 3 labors, they will have to do, we don't know how many days they have to do, make it x days. Then 3 labors, they have to work x days to complete 12 human days. In an equation you can write 3 into x, that is what, 12. So x means 4 days they have to work. So finally we can say, initially here 2 days they have worked, all 4. When one left, 3 remains. Then those 3 laborers, they have worked 4 days. Then totally they have worked 6 days. Then 5 days we have to complete with 4 people. Because of one left, we have to work one more day to complete the work. That is the answer. Again, I'll briefly tell you. 4 people, they are working 5 days, then this much of work they will do. But after 2 days, or out of these 5 days, 3 days, one laborer absent. That means only 2 days all 4 are working. Then this much of work already they have completed. Then we left with 12 human days their work. So this much of work they have to complete by 3 laborers. So it will take x days. This day we don't know. That equation says 3x equals 12, so x becomes 4 days. From this calculation, we found that totally they had to work 6 days instead of 5 days. So one more day they have to work to complete this work.